Hey, today we're going to talk again about right triangles and another special type of right triangle. And that's a triangle that has obviously one 90-degree angle, but also one 30-degree and one 60-degree angle. So the legs and the hypotenuse in this triangle, kind of similar to the isosceles right triangle, they have a special relationship. So we're going to call the leg across from the 30-degree angle 1. And since the 30 and the 60 aren't the same measure, the other leg's not going to be the same size. In fact, this leg is going to be the square root of 3 long, and that gives us a hypotenuse of 2. So when we have a 30, 60, 90 right triangle, we can use this triangle as our reference. The leg across from the 30-degree angle is 1. The leg across from the 60 is root 3. And the hypotenuse is 2. So we can use that idea just like we did with the isosceles right triangles, and we can create proportions. Since we have similar triangles, our reference triangle will always be similar to a 30, 60, 90 because they have the same angles. And so we can write proportions using the sides that correspond, and then we can use those to solve. So my side across from 30 is n, and we'll divide that by 1. My hypotenuse is m, we'll divide that by 2, and then the other side we divide by root 3. Again, they're only going to really probably show you one of the angles. Since that's 30, we have to know that that's 60. And so we can create these two proportions. What's nice here, and we talked quickly about that in the isosceles right triangles, is that whenever you divide something by 1, the divided by 1 is kind of unnecessary, so we can kind of get rid of that there. And then in this example, the 2 square roots of 3 can cancel, and so we're end simply with n being 7. Same idea over here, the 2 square roots of 3 can cancel. We have to multiply both sides by 2 to get rid of this 2 over here. And we get m to be 14. So we're using our reference triangle to create fractions. We're taking those fractions and making them equal to each other to make proportions. And then we're solving those proportions to find out the missing side lengths. So let's give this one a shot. This time we have the 60-degree angle. The side across from 60 will divide by root 3. The hypotenuse will divide by 2. And the side across from 30 will divide by 1. And so we can write our two proportions. Again, that divided by 1 is unnecessary. Anything divided by 1 just stays the same. And so to solve this for x, we multiply both sides by 2 to get x to be 4. To get y, we multiply both sides by the square root of 3. And so 2 times the square root of 3 will just leave as 2 root 3 to keep things simple here. So let's do one more together before I send you off to do one on your own. My side across from 60, I'll divide by root 3. My hypotenuse, I'll divide by 2. And my other side, I'll divide by 1. So I'll use those fractions to set up my two proportions. I'm using the 5 over 2 both times because there's no variable there. I'm going to solve for y because I think that's easier. We don't need that divided by 1. And so we end up with y being 5 over 2. For this one, we just need to multiply both sides by the square root of 3. You could cross multiply and it'll add an extra step, and that's totally fine if that's what makes you comfortable. So 2 times x and 5 times root 3. Or you can just do the 5 times root 3 and leave that divided by 2 right there, and you're done. X is 5 root 3 over 2. We can't simplify that further without turning it into a decimal, and so we'll just leave it alone for now. So I want you to use those 3 examples to help you do this one. I want you to find x and y. Make sure you do that before class. If you have any questions, make sure you're ready to ask those questions, and you can check your answers in class.